I am Dao Kyun. Today I will take you into the mysterious world of PLCs. Why can robots assemble cars in a specific order? Why can automatic production lines transport materials as required? What enables high-speed trains to move? Why can elevators ascend and descend automatically to different floors? Why can the lights at the New Year's Eve garden party change in a set sequence? Why can traffic lights on the streets control the flow of vehicles and pedestrians as needed? Why can musical fountains change according to a certain pattern? It's because these projects all share a common industrial control marvel, the PLC controller. Do you want to know how PLCs achieve this functionality? Would you like to design your own program to make an electric motor spin? Now, please pick up your phone or turn on your computer and follow me into the fascinating and challenging world of PLCs. Next, we will study the hardware foundation of PLCs. First, let's get to know what a PLC is. The full name of PLC is Programmable Logic Controller. PLCs are a new generation of industrial control devices formed by integrating microelectronic technology, computer technology, automatic control technology, and communication technology on top of traditional sequential controllers. The purpose of a PLC is to replace relays for executing logic, timing, counting, and other sequential control functions, establishing a flexible programmable control system. It has characteristics such as strong generality, ease of use, wide applicability, high reliability, strong anti-interference ability, and simple programming. In fact, it is a specialized computer designed for industrial control, and its structure is similar to that of a general computer. How did the PLC come into being? The protagonist of the story we're about to tell is something our public friends are extremely familiar with, the PLC. Let's welcome our special guest today, the father of PLCs, Dick Morley. Hello, everyone. In 1964, Mr. Morley was a young engineer working a 9-to-5 office job, designing aircraft radar, atomic bombs, and communication systems. Indeed, I quit my job later to learn skiing. You're truly a man of character. On April 1st of that year, I co-founded the Bedford Associates with George Schwenk, an engineering company based in New England. What does this mean? Before you created the control system, the main devices of control regulators relied on relays. Right, relays. To be precise, a multitude of relays. They were bulky and noisy, and their annual maintenance consumed considerable manpower and resources. The wiring, inspection, and maintenance of relay contactor systems also demanded a high level of proficiency from maintenance personnel. So you wanted to develop a product to replace relays, didn't you? Yes. Most of our project designs were completed with fixed controls for better reliability. For instance, we developed a programmable computer for hotel reservations, a tracking and navigation system for air and sea transport, and a radar system for personnel detection, all using solid-state control systems. After working on these projects for a long time, I felt mentally exhausted. I heard that on New Year's Day in 1968, after having a drink, you wrote the design requirements for this system. Yes. Then I discussed it with everyone, and we began to create this device. Mr. Morley, after you set the direction, how did you proceed? Later, we raised some funds and started another company called Modicon. Coincidentally, General Motors in the United States announced a major project that year, worth $1 million. Thus, Modicon sold the world's first programmable controller to General Motors, but at that time, this machine was not called PLC, but Programmable Controller, abbreviated as PC. Alright, Mr. Morley, that's all for today. Thank you very much. The true PLC was developed by the Digital Equipment Corporation in the United States in 1969 as the PDP-14, which was later named PLC and has since seen significant global development. PLC control technology has become an indispensable part of the industry. I believe you now have a basic understanding of PLCs. That concludes today's lesson. See you next time.